now that we've created a very simple script to move our objects around, we're going to try to do the same thing, but now with physics, so our game is more realistic. The first thing you want to do in order to enable physics in your game objects is to create a rigid body. So once you add this component to your game object, you have access to many different variables like the mass and the gravity, whether or not the object allows you to apply forces to it, and some constraints. So by default, if we hit play, we'll find that if we were to lift this object in the air, you'll see it's falling down slowly due to gravity being applied. Now if I do disable this, it's just like any other game object where the physics is not really being applied in terms of gravity in this case. Okay, so the first thing we want to do is we want to get the user's input and be able to apply movement. So let's create a new script calling it move pb, which means move physics based. And I'm going to disable the previous script and bring this new one in. And now I'm going to do a couple of things. The first thing I want to do, as before, is I want to get the user's input. So I'll create a float variable called player input. And this is the horizontal and vertical, or in this case, the forward and backward movement. I also need, in order to apply any sort of physics updates, I need to get the rigid body that I just created. So I'm going to create a reference to that. And I'm going to get this information at the very start. So the most useful kind of function for this is to get components. So you can always get any components that are attached to this, to the game object that the script belongs to. So in this case, the script belongs to the game object, the character game object, and so we can get any of the components. So I'm going to get the rigid body. In the update step, I'm going to get the user's input. So I'm going to say player input is equal to input.getAxis, and I want the vertical axis. Once again, let me quickly remind you that the input manager already has some default axes, so the horizontal and vertical axes already exist. The vertical one is the down and up key. So now I get the player input. Now, one other thing to keep note, and I think this is really important, I'm going to quickly cover this, is that Unity by default, if you want to do any sort of kind of updated, or when you want to change something every so often, you use the update function, which is called every single frame. And this is typically used for just about any update. However, when you do physics updates, you want to have something more consistent. So because this is tied to frames, it may not run the same way every single time, or as at the same frequency. So typically what we do is we use the fixed update. This is frame independent, so it runs at the same frequency. So every certain period of time, it's going to run this function and calculate your physics updates. And so we're going to use the fixed update in our script. So we're going to do void fixed update. And we're going to, by default, we're going to do the following. We're going to take the user input and we're going to apply it as a velocity. So as before, we want to get the rigid body, but now we want to apply a velocity to it. And this velocity is a vector 3. So what we want to do is as follows. So we want to get the user's forward direction, or the transform in the forward direction, and we want to apply the velocity. So we want to say that the velocity equals the velocity plus the forward direction of the character. So we have the transform. So in order to facilitate the transform, I actually need to get the player transform. So I can say transform, and I'm going to get that at the start of my script. So this gives us information about the user's like movement and rotation. So we can say get component transform. And now we want to get the transform dot forward, So this is the forward direction of the character. And what we want us to do is we want to apply this input as before to the to this input. So we want to say, give me the player input. We want to multiply it by this. Okay. So, oh, actually, okay, there we go. So now if I run this script, I should be able to move in the character's forward direction and backward direction. But you'll see that something weird is happening. And what's actually happening here is the following. So the character is tipping over. And so you'll notice that there are some constraints for this rigid body, but none of them are set currently. So by default, when I'm moving forward, I'm creating some sort of imbalance and causing my character to tip over. And that's actually happening in the Y direction. But what I can do is I can freeze the rotation in, for now, let's say all 3 axes, which means that my character won't topple over when I'm applying a change in velocity to the object. So now you'll see I'm able to move my character forward and backwards using physics updates. Okay. Now the next thing I want to do is kind of the same thing we did last time, which is we want to be able to also rotate our character in space. And there's many ways again to do this, but one way that what I would suggest is to get rotation input from the player. So we can say private float rotation input. So this is the user's input in the rotation, or to rotate the character. We also want to get the vector3 user rotation because we need to apply this update to that rotation. And what we can do is we can get the user's rotation input through another get axes, but now we want the horizontal axis or axis. If we go to project settings, we'll see that the horizontal and the vertical axes are mapped, or the horizontal axis is mapped to left and right. So we'll get that information here. And then what we want to do is we want to actually change the rotation as before. So user rotation is equal to transform, which is the character's transform, and get the rotation in Euler angle. So we want the XYZ rotation angles. Then what we want to do is we want to apply the change in the rotation. So if the user wants to rotate a little bit, let's say 20 degrees, we want to apply the change to the original rotation. So we'll take the original rotation, that's the plus equals part, and we're going to add it to the rotation input in the Y direction, because we want to rotate in the Y direction only. And now we have our user rotation. The last step is we want to actually change the value of the rotation, because we've calculated it, but we haven't applied it yet. So we have to take the transform rotation, and remember this takes a quaternion, so we want to get Euler angles. So we take our user rotation and we want to convert our 3-dimensional vector of XYZ rotations into the quaternion. And that way we set our rotation. So now let's go back and quickly have a look. So you'll see I'm able to rotate and move in the character's forward direction at all times, no matter which way I'm looking. Okay, cool. The next thing we want to do in order to make our platformer a platformer is allow the user to jump between platforms, right? So the first thing we want to do is we want to get the user's jump, whether or not the user has pressed the jump button. So let's create a Boolean variable which is telling us whether the jump is true or false. And so I'm going to call it user jumped. And what I'm going to do is I'm going to go to the update step, and I'm going to say user jumped is equal to input. And there's many ways to get whether or not the user has pressed a button. There is the key down, which allows you to actually map it to specific characters. Like for example, I want to see if the user pressed the button C. Oops. Right. But in our case, we actually can make it a little easier, because if we go back to project settings, there is a jump button that is mapped to spacebar. So we can just use the button itself instead of a key. So we can say get button, jump button. So whatever jump is mapped to, in our case the spacebar, will tell us if the user has pressed the jump button or not. Okay, so now if the user has pressed the jump button, we want to apply a force. And to a rigid body, you can apply force in many different ways. So let me just quickly show you. So I would also just want to highlight that the Unity documentation is quite good. So if you ever have any questions, this is a very simple way to kind of find out information about any aspect of the API. In our case, we want to apply a force, so rigidbody.add force. And by default, you want to specify the force as well as the mode. And there's a few different modes that the rigid body allows you to apply force with. You can apply a force itself. You can apply an acceleration, an impulse, or a velocity change. In our case, we're going to go with the velocity change because we don't really want to care about the mass. So what we're going to do, I'm going to say rigidbody.add force vector3.up. So because we want the user to jump in a specific axis, we always want to jump up in the y direction because y is the, so the y is the green axis here, and that's the world axis green. So we always want to jump in the world y direction. And so this vector3 allows you, vector3.up allows you to get this information. At all times it gives you the up axis. And there's a couple of different versions of this. You can get the right, the left, the forward, and so on and so forth, but we want the up axis. So we're going to apply it in the up axis, and we want to choose a force mode, and I'm going to choose velocity change for simplicity. And let's just try this out. So you'll see that the player is able to jump, but you'll see that the jump is super high, and I can actually hold the spacebar, and the character is jumping infinitely high. That's not something we want to do. And the player is still falling down. Okay. So one thing I didn't do is I don't want the user to jump immediately every single time. So we want to set the user jump to false at any given moment. So this should help us deal with, nope. So anyway, we're able to create the jumping mechanism. So we're adding a force in the y direction when the user presses the jump button. Now we can actually try to jump platforms. Oops. So we'll see we still need to tweak some of these values because they're kind of jittery. So one thing we can do is we can actually reduce some of these values a little bit so we can scale it. We can say private constant, so we can put a constant float. We can do something like input scale or something like that, and we can say it's 0.5 for instance, and so we can kind of scale the user's forward and backwards input by this amount. So this will help us with the player not moving so fast. So our jump still needs to be fixed, but on the whole, we're able to move our character, we're able to rotate them, we're able to jump between platforms.